Okay, we're recording now. So we're going to implement this print that is implemented in person. We're not like we're basically overriding it. So first thing we want to call is the print of person. So like we don't want to re-implement everything that we've printed in person. So we want to call the print, whenever print is called on student, we want to call the print of person first, and then we add on top of it what we want. So the way to tell the compiler that I'm making a call to the print function of person is by specifying the scope of it. This is the person print. So if I even highlight this here, it will tell me this is person print. If I highlight this, the print of student, it will show me that this is student print. So I'm gonna make a call to person print first, and then on top of, after that, I will add the output of student ID. So now if I go back to this here, and we run this again, now it's printing student ID. So now the print call is happening to, it's making a call to the student print and not the person print. This print function right here. Now, in the next tutorial, we're gonna look at much more into that, especially with virtual functions and virtual, like pure virtual and stuff like that. Which will make, like we'll do more examples about this and it will make more sense. But for now, like just keep it at this level. So let's implement the default constructor, the regular constructor of student. Now to construct a student using the regular constructor, we need to pass everything we're passing to person as well in the constructor. So I'm going to pass everything to person. And then I'm going to add a string for ID. Now, how do we initialize everything? We're going to make a call to the constructor of person, and we're going to pass everything to it because we already have the constructor of person, and we want to construct the person part of this class by calling the person constructor. So we're going to use the regular constructor of person and pass everything to it. And after that, we're going to initialize our student ID, which is part of our student class only. So this will be our regular constructor. This is our regular constructor right here. It has, we're passing all the parameters that we want to construct a full student, which means also a person. And all this is part of the person information, and this is the student part. But from the constructor outside, we're just constructing a full student. But to initialize the person, we're initializing by using the regular constructor of person here, by passing the parameters to it. And then we're initializing the student ID. So let's test this constructor from the main function. We're going to use the regular constructor here. I'm going to copy the information we passed to the previous constructor. And we still have the ID, which, okay. Now let's see if it prints all the information. And everything is working. We have all the student information being printed correctly. and constructed using the regular constructor. So now let's ask this question. If we're destroying student now, what gets destroyed first, student or person? And whenever you have a question like that, you can just do a simple experiment and find out. So we're going to override the destructor of person and say person is destructed. And we're going also to override the destructor of student. And say that student destructor. Now, what I'm going to do here is that I'm going to put the student in a smaller scope. What does this mean? Like before I added these two braces, the student will be destroyed once I leave the program, because this is the scope. This was the scope of student, but now I have a smaller scope of student. So like outside the scope right here, I cannot access student. It does not know what it means. Okay, regardless, I made a typo, but it doesn't know what student is as a variable, because student was defined within this scope only. So when it enters the scope, it will construct student object, it will print, and then it will leave the scope, which means that it will pop out from the stack anything that was added inside the scope, which is the student variable, which in other words means that it will destroy the student, and it will call the destructor of student. So I'll add the breaking point here. Although, like in general, there's no need for it, but just gonna remove the hello because we're not doing anything after it. Like later on, maybe we will add something. So what we see here is that the student destructor was called, and then the person destructor was called. So the way it will call the destructors, it will start with the object you are, like it's your student. So it will call the destructor of student, and then it will call the destructor of person. Okay. Now, if we want to continue implementing this undergraduate student, will be okay. This example, this code like has an extension for the next tutorial, which deals with virtual functions, which makes more sense. Which I don't have it here, which is good. Okay, so we're gonna stick with a simple example now, and then maybe we'll expand on this same code next tutorial when we deal with virtual functions. So for now, let's just, I don't know, what do you suggest we add to undergraduate student? Okay, let's add something like the maximum or minimum credits, let's say, per semester, for example. Okay, department. But is that a student or undergraduate student? I would say this is part of the student being in the department, specific department. So because such information would be common between all students, it would go inside the members of student. We can add it here, department. As long as you have something in common in the like a base class, you should put it there. If you have something very specific to under like the inherited or derived class, it will go there. So in here, let's say we have like some value. Let's make this static. Like this is shared with all the undergraduate students. So static maximum or minimum number of credits per semester. That is a very long name, but it's okay. It's descriptive. Can we initialize it here? Say 9. Okay, I need a type. Okay, we cannot initialize it in a header file as far as I know. Has to be in a CP file because it's a static member. Okay. Let's implement student.CP. By the way, I just put the student and undergraduate student in the same file, but which in C++ it is okay. But you like meaning that C++ would allow it, because in like Java you cannot. But it is better to put them in separate files with the file name to be the name of the class you're in or you're implementing. Okay, minimum whatever. This is an integer and equal to 9. So we have a static member inside the integer, static integer inside undergraduate student. We just initialize it to be 9. And we'll do the same for graduate students, or we'll add something else for graduate students anyway. So this is the constructor of undergraduate student. The default constructor, I would say we can leave it empty because we're not adding any new members, any new private members or something to the undergraduate student other than the public student. Because whenever the default constructor gets called here, it will make a call to the default constructor of student, which already does things as we want. Now for the regular constructor, we're going to copy everything that is in student. Not that is in student, that we're passing to a student constructor, and we're going to pass it to the undergraduate regular constructor. And then the way we're going to initialize everything by making a call to the student regular constructor and passing everything to it. Email, age, address, and ID. Okay, and that's our undergraduate student. Now we can also override the print function. And the first thing we're going to do, anytime you're overriding a function in a derived class, if you wanted to, like usually you would want it to call the function of the superclass, but not necessarily. Like usually you would want to do that, but you cannot do that. So if I don't make the call specifically, then it will not happen. So let's make the call to student print function. And then let's output as well if you want, just for the sake of the example, let's call it undergrad. Like just change that here. This is an undergraduate student. And then we make the call to the student print. Okay, do you guys have any questions whatsoever about everything we just talked about? Okay, from the source file, from the main function, we can construct an undergraduate student instead of a student. In this case, everything will work just okay because uh, the things that we're passing to the constructor are exactly the same. But now this is an object of undergraduate student and not student. Okay, so let's implement employee maybe. Where's our design? Let's implement employee that is takes person, that inherits from person. So we will create a new class, a new file for employee. Class employee, and it inherits public inheritance from person. Doesn't know what person is, so we will include person. Okay, so we'll have protected and private. Actually, sorry, protected and public. So now, similar to how we did with student, now employee inherits everything from person. So it has the name, it has the address, it has the phone number, it has a print function, and so on. Now, let's say it has employee has, let's say, salary, or it can have like well, let's just keep it simple and just have salary. Okay, double salary. Let's say this is like monthly salary. So this is the information an employee has, and everything else is similar to the person. So in this case, in the default constructor of employee, person will, like the default constructor of person will be called. So we just need to initialize salary in this case. Let's initialize it to 0. That's it. For the regular constructor of employee, we're going to need to pass everything that we pass to person to construct person, which in this case, similar to how we did the student, because this is all the same information. And at the end of this, we're going to add a double for salary. So the first thing we will construct here, or initialize maybe, is the person class that we inherit from. So person, we're gonna make a call to the regular constructor of person and pass all this information. And then we will initialize salary. And this will be our regular constructor of employee. Now, one last thing we will do is we will override the print function from person. The first thing I will do is make a call to the person print function. And then we can output salary And this will be our class employee. So going to the main function here, let's create a employee. Let's include first employee. And here I will create an object of employee. So rich. Okay, this is my monthly salary. And let's print employee. So in here, we're making a call to the regular constructor of employee. And then we are calling print on employee. So this is an employee object, which is within the scope as well. I mean, there's no need for it at this point, but it's okay. And let's add a print here call just to separate between the two. Okay, so this is our student. Now, because it's an undergraduate student, we can see that it's printing undergraduate student, because that's what we implemented in the print function for undergraduate student. And this is the information of the undergraduate student. And this is the employee. It has monthly salary here. And we're seeing the outputs of the person destructed because we added those. We're not seeing the output of employee destructed because we simply did not override the destructor and we did not implement the destroyed the output that person is being destroyed. Okay. Anyone have any questions? Do you have any questions about anything related to the material of inheritance or class composition or anything that was covered in the lecture that I did not go through today? Okay, I have one person saying no. I don't know about the rest. So looking at the slides from the professor, I see that like you ended the class kind of just by understanding what is private versus protected and how to inherit from something and the difference between the types of inheritance. I'm assuming next lecture will be on more like advanced stuff in inheritance with virtual functions and stuff, which we can cover it afterwards. But if you understood everything we covered today and you don't have any questions, like we can end this tutorial and just go eat. Okay. Yes, I can explain protected once more. Are you asking about having protected as accessor like this, or is it about the inheritance, protected inheritance? Or both? Okay. So we know what is private and what is public. When you have members being private, it means that you can access them. Like when you have members that are public, it means that you can access them from outside. Private, it means that only the class can access them. Now, when we're doing inheritance, now we have a third player here, because like it's not necessarily like being that a derived class can access your information is like a third category. It's not necessarily private and it's not necessarily public. And this is where protected comes in place. Protected means that, so if you have private members here, it means that the derived class will not have access to this directly. And the outside, from outside the class will not have access to it. So no one have access to it except of this class only. Public means the outside have access to it, so that's the inside. But protected means that if you, like the outside does not have access to it, but if you inherit from it, if we inherit from employee right now, say professor is an employee, now professor has access to salary, but it doesn't have access to this whatever. I can show you that by trying to print it. So inside the default constructor, we'll try to output salary. We have access to it. We'll try to output whatever, and we'll get an error saying that it is inaccessible. Because this member, it is still a member of professor, by the way, because everything inside employee is now within professor. It's just that professor does not have access to this private variable right here, or private member, because it was private in employee. Now, salary was protected in an employee. It means that it is protected from the outside, but if you inherit from it, you can get access to it, which in this case, we have access to it. So this is the difference between private, protected, and public as a access modifiers for the members. Is this part clear? We move on to the like the difference between inheritance, public and private and protected inheritance. Okay, so now the question is, what does it mean to have public inheritance, protected inheritance, or private inheritance? So if you have public inheritance, it means that everything that was public in the base class now stays public in the derived class. And everything that was protected in the base class now stays protected in the derived class. The private, you don't have access to them regardless of anything. We just saw an example of how we don't have access to private members. So what does that mean? So going back to our example, this employee class has a function called print. And this professor here is inheriting from employee, and it's inheriting with public inheritance, which means anything that is public in employee is public inside, is public for professor. It falls here. It's a public thing. It will just be passed to everything that is public in employee is public inside professor. And everything that is protected inside employee will be protected inside professor. If we go to our main function, and let's construct, instead of an employee, we will construct professor here. And we will make a call to the print function. Now, right now, this is the print function coming from employee. Like you can even see it highlighted here in the IDE, that this is the employee print function, because we inherited everything from professor, inherited everything from employee, which includes the print function, which was public, and we're doing public inheritance, so it stays public. And that's why we can access it from outside, because it's a public method. However, if we change the way we're doing the inheritance, instead of public inheritance, we will do protected inheritance. Now, based on our diagram, everything, this is the protected inheritance, everything that was public in the base class now has become protected in the derived class. It is not public at the professor level anymore. It is protected, which means our print function is public and employee, but inside the professor, it now falls under this category here. So this is where the print will be, which means that from outside, we don't have access to it anymore. And if we go to the main function, we should see that now we have an error. It's saying that print now is inaccessible. It was accessible because we were inheriting public inheritance. So everything that was public stayed public in professor. But now because our inheritance became protected, everything that was public has become protected. And protected means that from the outside, we don't have access to it. So we don't have access, it's inaccessible anymore, the print function. But from the inside, it is still accessible. So inside the constructor, for example, we can still call print because protected means that it is accessible within the class itself. And it means that it can be passed to the derived class. Now, private inheritance means that everything that was public or protected has now become private. So they would fall under the private category. And if you make private inheritance, it means that everything you are inheriting cannot be accessed anymore under any other derived class. If I have here a new class that I'm inheriting from professor, say part-time professor, that inherits in whatever way from professor. So if this professor is inheriting privately from employee, it means everything it took from employee has now become private here inside the professor, which means regardless of the way you're doing the inheritance for the part-time professor, you don't have access to them anymore. I cannot access print. Okay, I shouldn't be able to do that even if I have access to it, but let's create a default constructor. I do not have access to print anymore because print inside employee was public. We did an inheritance here from professor, from employee to professor privately, which means print now has become private and not public anymore or protected. It is private, which means when we do inheritance from professor to part-time professor, whatever is private, we don't have access to it anymore. So if you're doing private inheritance, it means that it's like you're adding a restriction to anything that will inherit from this class now, because anything that inherits from professor at this point, regardless of how you do the inheritance here, anything that you inherit from professor, that class will not have access to any of the inherited members because they all went private. Okay, please ask me what part of this you didn't get or any questions you have. Okay, now this part of the tutorial has been recorded, so I'll put it on YouTube as well. Next time, like if I forget to record, start recording, make sure you remind me at the beginning also. Okay, so if you guys don't have any more questions, I guess we can sign the attendance and can end it here. Next tutorial, we will review this whole inheritance thing and we will do more examples with virtual functions. I hope, I think that you will have covered it next tutorial.